All right, guys. So, welcome to our mathematics class. So, in today's class, we are going to discuss another important topic, which is very important for all of us to know. And please make sure that you follow up and you are free to ask questions where you feel you need some clarity. So in today's class, we are going to look at the rational numbers. So last time in the previous lecture class, we discussed the sets of numbers, and we concluded on that particular part. All what is needed is for us to cement and to also go through the tutorial sheets and also some exam past paper questions which are in your assignments, the one I gave. So we'll start our class. The first thing is for us to define what irrational numbers are, and we should be able to know what these guys are. So if you look at the definition of rational numbers, so rational numbers, I'll write my definition. So rational numbers are numbers that can be expressed in the form P over Q. So rational numbers are just numbers that can be expressed in the form P over Q or A over B. P over Q or A over B. So this is the first definition that you guys are supposed to know when it comes to rational numbers. So in other words, or in other terms, so when you talk of rational numbers are just fractions. So rational numbers are fractions. So rational numbers are fractions. So for them to be fractions, that means that rational numbers are also decimals. So rational numbers are decimals. So rational numbers are fractions, and also rational numbers are decimals. Okay, so that's the thing that you need to understand when you talk about rational numbers. So from the point which has been raised, we have talked about decimals. So when you talk of decimals, you need to understand that we have two types of decimals. So these two types of decimals can be classified into two ways. So we have recurring decimals and non-recurring decimals. We have recurring decimals and non-recurring decimals. Or these decimals can be said to be terminating decimals and non-terminating decimals. So we have two types of decimals you can talk about. You can talk about the terminating decimals, terminating decimals, and the non-terminating decimals. Okay, non-terminating decimals. So these are the two types of decimals that you need to understand: terminating and non-terminating decimals. And also you can talk about recurring and non-recurring decimals. So those are just the other terms that are used when you talk about decimals. So example, I'll write there. An example of a terminating decimal is let's say 0.25. So 0.25, it is a what? It is a terminating decimal. So 0.25 is a what? Is an example of a terminating decimal. So if you look at 0.25, this can be written as what? 1 over 4. This can easily be written as 1 over 4. Then another example I can get when you talk of terminating decimal, you can talk about 0.5. 0.5 is the same as 1 over what? 2. So these are the examples of what? Examples of terminating decimals. So these are decimals that have no repetition, and these are decimal points that have an end. So the other one which you need to consider when you are talking of the type of decimal, it is the non-terminating decimal. So if you look at the non-terminating decimal, a very good example I can give is 0.3333333 like that. So I'll put dots because I'll put three dots just to show that this this decimal is keeping on repeating itself. And then this guy can be written as 0.3 bar on top. Okay, we are not going to continuously write 3333, and we are avoiding writing 33 and 3 dots to show that it is keeping on repeating itself. So to avoid writing such a thing, we just say 0.3 bar. Okay, so the bar is just telling you that 3 is repeating itself. So this can be written as 1 over 3 in terms of decimals. So this is the first example of a non-terminating decimal I can give. Then the other example I can give is something like, let's say I'll put it as my 2. Let's say I have something like 1.42. Let me put a number like this one. I hope it will work out. So 1.4271428 and so on and so forth. So this is also a non-terminating decimal, and this decimal is just equivalent to 8 over 7. So if you press on your calculator, you are going to have when you say 8 over 7, 8 divided by 7 is going to give you such a number. So this is an example of a non-terminating decimal, and this is the summary of what we can talk about when we are talking about rational numbers. With the ranges that are taking place, are you guys able to get what I'm saying? Are you following? Are you understanding? I really don't want to teach and then people don't get anything. I want to whereby everything is understood and we get those good grades. Are you guys following or not? If not, we can have it tomorrow with biology, because these days we'll be having 2 classes.
We are following, sir.
Alright, since we are following, we are going to move. So please guys, here the examiner would love you to be able to define a rational number. So you as a student, you should be able to define a rational number. A rational number is a number that can be expressed in the form P over Q or A over B. Okay, so with that information, we can now quickly look at examples. We can now quickly look at what examples. Let's quickly look at the examples, and you guys should make sure that you ask where you are not clear. Okay. So my example is show that each of the following, show that each of the following, show that each of the following, show that each of the following real number is a rational number, is a rational number. So this is our question, and A, we have been given 1 point, okay, let's put 3.3 bar, and then B, we can have 25.12 bar, and then C, we have, let's say 3, we can simply say 0.2, and then we can say 9432 bar on top. So this is a very easy task that you are going to have. Sometimes they won't say show that each of the following real number is rational number. Sometimes they would prefer saying express each of the following in the form P over Q or A over B. So those are just some of the ways in which this question is phrased. So solution. So I'm going to pick my A, which is 3.3 bar. Okay, so if you look at 3.3 bar, 3.3 bar is simply saying that 3 is being repeated. Okay, 3 is being repeated. So the first thing that you need to do, I'm repeating that and I'm emphasizing on it. The first thing that you need to do is count the number of decimal places. So how many number of decimal places do we have? Correct. So we have 1 decimal places. So since we have 1 decimal place, we normally use the multiples of 10. Okay, you normally use the multiples of 10. I'm repeating that. You normally use the multiples of 10. The multiples of 10 are the ones that you need to use, like this one. I'll name this guy as Mr. Ben 10. So Ben 10, that's his name. You normally use the multiples of 10, so you're going to use things like 10, 100, 1000, 10,000, depending on what? Depending on the number of decimal places that you have. So since we have 1 decimal place, we are going to use 10. Okay, since we have 1 decimal place, we are going to use what? 10. So we are going to say let's 3.3 bar be equal to what? X. Then okay, let 3.3 bar be equal to X. Then we are going to multiply this expression by 10, since you have 1 decimal place. So you are going to multiply by 10. So you are going to say 10x. Okay, so 10x is simply equal to, when you multiply this by 10, this will be 33.3 bar. The reason why you are having a 3.3, another 3, because this particular number here is the same as 3.33333333333 and so on and so forth. So to avoid writing a lot of threes, we just put a bar on top. So to get to get rid of this bar, when you multiply by 10, this point will just go to that point there, and this point will be there. So that's why you have a 3 there. After you do that, you're going to say, then the next step is for you to subtract. Okay, the next step is for you to subtract this one and that one. So you're going to say 10x is equal to 33.3 bar. Then you do what? You subtract this one, which is just x is equal to 3.3 bar. Okay, so with that information in mind, where you are now subtracting this expression from that expression, so with that in mind, you can simply say 10x minus x, it is what? 9x is equal to, then you say 3.3 bar minus 3.3 bar, the answer is simply 30. So when you have such information, you can now easily find the 9x. You can just simply say 9x is equal to 30. So you divide throughout by 9, you divide throughout by 9. So that one and that one goes. So when that one and that one goes, you are going to have x is equal to 3 into 30, it is 10. And 3 into 9, it is what? It is 3. And this is the what? A rational number, which is a rational number, which is a rational number, like that. Easy, because this is the same as P over Q. Then you have done a good job. You have proved that this guy is a rational number. Guys, do you have any questions before I move on? Do we have any questions? Any single question? Florence, what's your question?
Sammy, I'm confused where you got the 3.3 bar and the 9x is equal to 30.
Okay. 3.3 bar. You haven't understood on that part where I was explaining terminating and non-terminating. So remember, non-terminating, they have repeated numbers. You get? Non-terminating, they have repeated numbers. They have numbers that are repeating themselves. You get? Like in this case, 0.333333. Then I've put ... This is telling me that 3 is repeating itself. 3 is repeating itself. So instead of me writing 0.33333333, I'm just going to say 0.3 bar. The bar on top is telling me that 3 is repeating itself. 3 is repeating itself, like that. Is that okay now? So in this case, 3.3 bar, it's just simply mean that 3 is repeating itself. Now since we want to express this guy into a fraction, we are going to say let x be equal to 3.3 bar. Let this x be equal to 3.3 bar, which is in our question there. Then because we have one decimal point, we want to get rid of this decimal, this guy, this bar here. You are going to multiply it by 10x, 10x, because you have one decimal point. Then after that, you're going to get this first expression and the second expression. You subtract them. So when you say 10x minus x, 10x minus that x, it is 9x. Then the 3.3 bar minus 3.3 bar is equal to 30. That's where this one and that one, they have been subtracted. Is that okay, Florence?
Still not very much clear. Okay, let me say 10x is equals to 3. Where did you get the 3.3 bar?
When you multiply this, that's why I wrote this part. I said 3.3 bar is the same as 3.33333. Then I explained that when you multiply this 3.333, you multiply it by 10. This point will move to the next part. It will move there and it will go and sit there. Then this expression can be 3.333, but we don't want to repeat the 3 3's. We are going to just put a bar to tell us that the 3's are repeating themselves.
Right, yeah, thank you very much. I've understood.
Alright, thank you. Let's move on and look at the next one, which is our B in this case. So our B is as follows. So the B there is that we are changing it 25.12 bar, 25.12 bar. So easy, you do it easily. You say let's x be equal to 25.12 bar. Then Taonga, tell me which number are we going to multiply it by?
100.
Correct. So we are going to say 100x is equal to, Florence, when you multiply 100x by that, what are you having? Florence?
100x by what?
100, not 100x. 100 by that, what are you having?
I'm getting a 2.5.
No. So you're going to say 100 because we have two decimal places. So you're going to say 100 by x, it is 100x. 100 by that, it's going to give you 2512.12 bar. Okay, so I've observed that Florence is a bit behind there. So this number is the same as 25.1212121212 like that. Now when you multiply this number, for us to get rid of that decimal point, that bar there, we multiply it by 100. So when you multiply it by 100, what will happen is that the point will move 2 times. So it will move 1, 2. So this will be now 2512.12, 1212, and so on. But this can just be written as 2512.12 bar. Is that okay? Is that okay?
Yes.
Okay. So the next thing is now for us to get this one and that one. So you're going to say 100x is equal to 2512.12 bar. Then you subtract 20. You subtract x you subtract x is equal to, you say 25.12 bar for us to get rid of the decimal points there. So when you work out that, this will be 99x. 99x is simply equal to 99x is simply equal to when you subtract there, this will give you 2487. So after you reach that particular point, you can have 99x is simply equal to 2487. Then you say over 99, you say over 99. This one and that one goes, so you have x is equal to there is a number which can go into this one and that one, which is a 3. So 3 into 2487 is going to give us 829 over 3 into 99 is just 33. So this guy is just a what? A rational number, because it's in the form of P over Q. Do you have someone with questions at that particular point, so that we make sure that we are moving at the same pace? Okay, let's move on. Let's look at let's quickly look at the next one. Let's quickly look at the next guy. So the last one, okay, I can see Florence has a question. J, I don't know how to pronounce your name. Jemina Ghost. What's your question first? We'll start with you.
Okay, so my question is, after you subtracted from 100, I don't know what you did to the other side.
I subtracted this one minus that.
When you subtract, it's like 2,512.12 bar. Then I don't know where 25 bar is coming from.
25 bar is from the first expression. 25 bar is from this. So we are subtracting this expression and that expression. These are the two we are dealing with. You now get?
Yes, I do.
Okay. Anyone else? Yes, Florence.
Alright, I wanted to ask about the 99. Is it following the decimal points whereby, let me say, if we have 2 decimal points, it will be 2 decimal points, then meaning the 9 will be doubled to 99, or
No.
or there is something that is supposed to.
The 99 is coming from 100x minus x. 100 is more like 100 minus 1. That's the 99. But here we have 100x minus x. That's the 99x. You get that now? Florence, have you gotten the point?
Yes.
Okay.
Yes, I've understood.
Okay, let's move on and look at the next part, the last part of our today's class, which is a C. So for this one, it's a little bit different from the friends. This one is a little bit different from the friend. So that then there is 29, there is 4, 3, 2, and then bar there. So what you're going to say, you're going to say let x be equal to 0.29432 bar. But if you look at the bar where the bar is a bit far from these other friends. The bar is not on all of these guys. So the first thing is you have to count the decimal places for those without a bar. So for those without a bar, you need to understand how many are there. Taonga, how many numbers don't have a bar on top? Okay, there are 2. So you're going to say times 100 x is equal to, you're going to say 29.432 bar. And then you're going to say, then the next thing you need to do now is for you to look for those with a bar, but you include even those without a bar. So meaning you are now going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you are going to say 100,000 x is equal to everything will close, so it's 29,432.432 bar, like that. Is that okay? Is that okay? I'm saying the first thing, the rules are the same. The first thing now, since not everything is on the bar, the first thing that you need to do is count those numbers without a bar. So the numbers without the bar are 1, 2. The numbers that are not repeating themselves are 1, 2. So you're going to multiply that by 100 and that by 100. So that 100 by x is 100x. Then 0.29432 by x is going to be 29.432 by 29.432 bar, like that, because this will move 1, 2. Is that okay? Then after you multiply by 100, the next step is to count everything there now. So when you count everything there, you have 1, 2, 3, 4, 5. So you look for a number, a multiple of 10, which has 5 zeros. So you have 1, 2, 3, 4, 5. So you say 100,000 x, you multiply by that. So 100,000 times x, it is 100,000 x. Then 100,000 times that, it's going to give you 1, 2, 3, 4, 5. But these 432 are repeating themselves. That's why you have seen them there. Is that okay? I don't know what. Is it okay? Okay, I think it's okay. So the next thing is, remember in the first 2 examples, I was getting this one and the last one, right? But in this one, we are not going to get this one. Instead, we are going to get this other one, like that. So these are the 2 now we are going to subtract. These are the 2 we are going to subtract. In such a case, this is what now we are going to have. So we are going to say 100,000 x is equal to 29,432.432 bar minus, you're going to say 100x is equal to 29.432 bar. Then you subtract these 2. So when you subtract these 2, this is what you are going to have. 100,000 x minus 100 is going to give you 99,900. So 99,900 99,900x is equal to this figure minus that figure there is going to give you 29403. 29403. Then after that you can get those guys, you can simply get those guys. You say 99,900x is equal to 29403. Then you divide throughout 900, then you say 900, then you divide throughout. So you cross that, you cross that. X is simply equal to, so if you look for a number which can go into this one and that one, the simplest way it will be 1089 over 3700, so 3700, which is also a rational number. Then you're done. So you don't have to leave it there. You need to look for a number that can go into that and that, and you don't have to use a calculator, because I know some of you are using calculators right now. So ladies and gentlemen, this is it on our lecture about rational numbers. So that means that my next lecture will be on irrational numbers. There are some videos that are there on our YouTube channel for revision of this particular topic, the revision of this particular topic. So when you go to our YouTube channel, you go to this particular topic, you can watch the videos and you can revise. Yeah, you can revise along. So for this one, this is a lecture class, and the next one I will be doing is irrational numbers. So I don't know if you guys have a question. Please, if you have a question, feel free to ask. Feel free to ask. Yes, Florence, what's your question?
No, just to be sure, where have we gotten the 100,000?
100,000 is coming from the number of decimal places. We have 1, 2, 3, 4, 5. According to what I said, you need to use the multiples of 10. Which part did I talk about that? Should be example A, the first example. Yeah, you need to deal with the multiples of 10. Yeah, that one, I think I wrote it there, the multiples of 10. So that 100,000 is coming from 1, 2, 3, 4, 5. So the multiples of 10 with 5 zeros is 100,000. Is that okay?
Yes, it is.
Okay. Alright guys, so I'll share this video on our YouTube channel, and I'll also share the links to the videos on this one, which are they are short videos, less than 15 minutes, and you can revise along. Alright guys.